Number 1, in the two cases below, calculate the diff value, which is the difference of means value, as directed, and write a sentence explaining what the sample mean of A minus the sample mean of B means in the context of the problem. So our diff values are just the difference between the means. So we're finding A minus B. Group A, 8 dieters lost an average of 8 pounds, so X bar, the sample mean of A is negative 8. And B, 8 dieters lost an average of 2 pounds over the same time period, so the sample mean of B is negative 2. Calculate and interpret X bar of A, so negative 8, minus X bar of B, minus 2. Negative 8 plus 2 is negative 6. So what does this mean? What does this calculation mean? What does that negative 6 represent? Well, what is it? We can see just from the numbers here, the 8 dieters lost 6 more pounds than the non-dieters on average. So the average of those 8 dieters, they lost 6 more pounds than the average of those 8 non-dieters. The second example here, I have 20 squash that have been growing in an irrigated field that have an average rate of 1.3 pounds. In group B, I have 20 squash that have been grown in a non-irrigated field that have an average rate of 1.2 pounds. So calculate our difference value of X, the sample mean of A minus the sample mean of B. A minus B gives me that the sample mean of A minus the sample mean of B is 0.1. What does that 0.1 represent? That means the weight of the irrigated squashes is on average 0.1 pounds larger than the non-irrigated ones. So we can subtract numbers, but the big idea is, can you interpret it? Do you understand what it means to do sample mean of A minus the sample mean of B? The weight of this first group was bigger than the second sample mean by 0.1. So using the randomization distribution shown below, what is the probability of attaining a difference of mean value that is negative 0.6 or less? So what's the probability of getting a difference that's less than or equal to negative 0.6? Is this difference considered statistically significant? Why or why not? So the way that we do this is we go to our our re-randomization distribution here, our sampling distribution, and there's 0.6. There's my cutoff. So I need to figure out what is that probability. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, that's also 9. 2, 3, 4, 5. 2, 3, 1. So the probability is 1, 4, 6, 11, 29 out of, if you were to go through and count all of these up, it's going to be 100. So there's a 29% chance of obtaining a difference in means, x bar minus x bar of b, a difference value that's less than or equal to negative 0.6. There's a 29% chance of getting negative 0.6 or more extreme, further away from 0. So is this statistically significant? This diff value is not statistically significant. This diff value is not statistically significant. I gotta get that out there. Statistically, because the probability of getting a difference that's less than or equal to negative 0.6 is bigger than 5%. Remember, 5% is our cutoff for saying things are unusual. So this happened 29% of the time. That's not that unusual. 29% is not that unusual because our probability is bigger than that 5% cutoff. Medical patients who are in physical pain are often asked to communicate their level on a pain scale of pain on a scale of 0 to 10, where 0 means no pain and 10 means the worst pain. Due to the structure of the scale, a patient would desire a lower value. We want lower values. We don't want pain on the scale after treatment for pain. Imagine that 20 subjects participate in a clinical experiment that have a variable of change in score is recorded for each patient, as the patient's pain scores after treatment minus the subject's pain score before treatment. Since the expectation of the treatment would lower the patient's score, you want negative change in score values. We want negative values here because that means they're feeling less pain. So for example, a change in score value of -2 would mean that the patient was in less pain. For example, now at 6 it was at 8. So they went down 2. Their change in their pain level went down 2. Below is a re-randomization distribution of the value of x bar of A minus x bar of B based on 100 random samples of these 200 observations. So we have a re-randomization score, and remember, we want the negative values. We want negative values. If Group A represented a group of patients in an experiment who received a new pain treatment and Group B received a pill with no medicine, how would you interpret a pain score of -1.4? So A received treatment, B received a placebo. So B is our control. So they calculated the difference of means. So treatment minus control gave me a -1.4 pain scale units in context. So Group A, the treatment group, score was 1.4 units less than the control groups. And this is actually good that the treatment group is less than. This means the treatment group felt less pain. Because that score is negative, that means that Group A actually felt less pain. Do we consider that diff score of -1.4 to be, would you consider that to be statistical evidence of the new treatment being effective on average in relieving pain? So is that diff score statistically significant? So let's go back to our distribution here. We had a diff score of -1.4. There's the cutoff there. How many were less than that? Only 4 dots. Only 4 dots were. So the probability that our diff value, or x bar minus A minus x bar A minus x bar B, is less than or equal to -1.4 was only 4 out of, there's 100 dots in that distribution. So the probability that the difference is less than or equal to -1.4 is 4 out of 100, which is 4%. This value here, this difference value, is statistically significant. That value is statistically significant because it's smaller than 5. So would you consider that to be significant evidence of the new treatment being effective? Yes, we would consider the sample mean of A minus the sample mean of B equal to -1.4 being statistically significant because the probability of it occurring by chance is only 4%. So because our diff value, the probability that it occurs was only 4%, that's not likely to happen by chance, so there is a statistical significance to that value. So we can say that this treatment is effective. We can say that that treatment A is actually effective compared to that control group.